So I'm basically going to talk about how you can do, how you can secure your mobile applications. Um, so before I start, good morning, everyone. I can see everyone, moving around. So let's start off with uh, about me. So I'm Subho Halder. Uh, I run a company called AppNox. It's into mobile application security. And what we do is we find out security issues in mobile apps. And today I'm going to show you some few demos as well as why mobile security is important. Now, in the previous talks, we all heard about smart cities and IoT and so many other tech, Kubernetes being deployed. But at the end, smart cities and IoTs basically interface with your mobile devices. And all of these different things which are out there kind of somehow meets in the middle where mobile is a very important device. And that is why security for mobile apps are really, really important. So even before I start, I want to talk about the first important point. Why is it required, right? So the first thing is there's a lot of different fragmented applications, which means that an app for Facebook, for Android tablet is a little bit different than the app which is there for phones, which is a little bit different than app which is there in an iPhone. And of course, an app for an iPad is also different than an app for an iPhone. So there's a lot of fragmented applications which are out there in the market. And that's one of the biggest problems for developers to have a standard across all of these applications for security purpose. The second is fragmented platforms. Android, even though the latest version of Android is out there, but less than 2% of the phones which is out there in the market are using the latest version of the Android. How many of you have an Android phone? OK, how many of you have updated it to the latest Android OS? Oh, just one, two, three, OK. That's good. But mostly people don't upgrade it, right? And mostly you still remain in the later version of the Android. And as an app developer, you have to support all the range of Android devices so that you get a lot of the market shares which is out there, right? So again, fragmented platforms, fragmented applications. But the last thing which is very important is personal and social information. So for example, if you have a Facebook app with your account logged in, and if I come and ask you, can I please check my Facebook? You're not going to log out from the Facebook app and give it to me to log in, and I'm not going to do that, right? Because it is so personal. All your banking applications, which is there on the phone, are pretty personal to you. So all your banking information, all your one-time passwords come to your phone, all your digital information about yourself, everything is stored in the phone, but not in your laptop. Your laptop may be an accessory to your IT interface, but your phone is where all your personal information are there. And the last is business and enterprise data. So if you're working in big companies, you might be accessing, emails and for your corporate emails, corporate documents. What happens if your phone gets lost? That's one of the biggest headache all the enterprises and business companies has. So these are the different scenarios why mobile security is important. But this is the business stuff, right? So and the other stuff, from the security angle, the data breaches, right? The amount of data breaches in the mobile have significantly grown. It has grown to 200% since the last 2 years. So you might have heard about username and passwords getting leaked in dark web. You can basically go to haveibeenpawned.com and figure out whether your username and password has been leaked. So that's data breaches. Mobile malwares, this has grown huge. So if I'm going to take an example, recently, last month, if you heard about this application called Cam Scanner, which scans your document and saves it as a PDF or a picture. So the problem with this is, even though the developer did not develop a malware, I mean, you guys are developing really good softwares, but you may be using third-party APIs, for example, ad APIs, just to earn some more money. But what if those third-party APIs and SDKs which you are using suddenly turns into a malware? Exactly the same thing happened with Cam Scanner. With more than 1.3 million downloads and users coming every day, they has to take down the whole application from the store just so that the malware which was discovered by the security researchers in the field, they had to remove the app and then re-upload the app once again after almost 14 days. Just imagine the amount of brand effect which it has affected, right? So the third thing is business worry about smartphone risk, of course. If you are utilizing your emails and your corporate documents, what happens to those documents, right? Cyber attacks on mobiles are increasing day by day because if you're attacking a laptop or a system, it may not hold such valuable information. Rather, if I can attack your mobile device, it has a lot more of information, and I can basically steal your identity, do many things. Now, I'm going to show those examples later on. And the last is the privacy leakages, right? So GDPR is one such data privacy law which came out in EU, and it's been appreciated all over the world. And the thing is, there are companies which basically collects all your address books, all your SMSs, email addresses, just so that they can calculate a score or an individual score for you. So this needs to be protected. So privacy is another very big thing in mobile security. So I've discussed about the business aspect. I've discussed about the security aspect. What about the technical aspect? Why is mobile security important? How many of you agree that, of course, you can see the slide, but how many of you agree that Android applications are written in Java? Of course, you saw it. But Android applications are not written in Java. They are written in something called Apache Harmony, and OpenJDK is another distribution which got a lot of push from IBM. IBM was supporting Apache Harmony, and the latest Android version has OpenJDK implementation. You might have heard about this big class action suit between Oracle and Google. It's because of all of this, right? But Google never used a proper Java internals. They always used something called Apache Harmony, which is the open source implementation of the Java symbols. I'll just give you a small example of this. So let's do this. OK, so I have an emulator open. It's an Android emulator. It basically emulates your phone. And this is my terminal. I'm just going to make it big so that you guys can see. Now, a very sample app. OK, let me just remove the. Yep. OK, so a very sample application of Hello World, right? It's so simple. So this is a sample Java application which you write, right? Public static void main. You need a main function for it to run. Then you have a system.out.println, and then you write hello world. Simple, right? And to compile this, of course, you need to do a Java compilation. And then to run this, you can just say Java hello world, and it says hello world. Now, my simple question is, if you were writing a Java program, can you run the same thing in your device? Of course not. Because Java uses a Java virtual machine. In this case, the JVM is based on a stack-based instructions. But what Android uses is something called Dalvik VM. It's similar to JVM, but it is based on registers-based VM. So to convert this .class file, basically, the class file is the machine code over here. So to convert this, we can use a utility called dx, and I can output it as classes.dex. So if I list it, there you go, classes.dex. If you want to see what kind of file this is, quick check. It's a Dalvik dex file, version 0.35, which tells that this is not a Java file anymore, right? I've converted this machine level language into a Dalvik level language, which can only be understood by the Android virtual machine. So now to run this, very simple. I'm just going to do a zip. So I'm just going to create a test.zip. It's similar to a jar thing. Like you can combine all the classes into a single jar file. And I'm going to use this utility called ADB, and I'll push the zip file into the device, the emulator which is running. I'll just get inside the emulator and go to the location where I had pushed it. So I'm not going to give you much details what exactly is data local time. That's not the part of the presentation. The part of the presentation is how a Java application is way different than how a mobile application looks like, right? So as you can see, test.zip is here. Now, how can I run this? Very simple. So I'll just say dalvik VM. It's not Java, it's dalvik VM minus CP. That's the class path. Would be the jar file, in this case, the zip file, and obviously the name of the class. And if I press enter, it says hello world, right? And to see what did the Android do, so logcat would show you the logs. Oh, sorry, I just cleared the logs. Let me run it once again. And as you can see, it loads something called libjava core, because there are Java symbols which I'm using, and this libjava code is loaded to figure out those symbols and then run it. Now, I went a little bit more tech. The reason why I wanted to do this was I wanted to show you how it is so different than a normal Java application. So securing our application won't work if you use a normal Java-based security analysis tool which is out there, right? Because for a phone, there is nothing called public static void main, and you do not run an app using like that, right? You click on an app icon, it runs. You get a text message, it runs. You click on a web link, it runs, right? So there are many entry points. The entry point is not just a public static void main, and that's a simple example via which I can show it to you. So securing your applications is pretty important, and there are different steps for that. So these are the different steps which I've analyzed, and these are the steps which have been followed right now in the world. The first thing is static analysis, of course. That's the code scanning. Basically, go through your source code, figure out where the problem is, the configuration level issues, secure coding practices, all of these has to be followed. That's just 30% of your overall security posture coverage. Followed by a dynamic analysis. So basically, you run the application and you figure out what does the application do. Does it save your username, password, your national identity, social security number, whatever? You go through all of those and figure out whether there is a problem in that or not. Followed by network analysis. Now, most of this mobile application, actually all of the mobile applications are client-side applications only, which means the code is available to all the users. It's not a Java servlet application running on a server, or you do not have access. It's a client-side application. Since it's a client-side application, most of the application connects back to the server. So the network analysis is also very important. And I'm going to talk more about that. And in the end, obviously, manual assessment. So not only you do all of those, but you also have to perform a manual pen testing on top of that to figure out business logical issues. So I'm also going to talk more about that later on. So a group of people formed this organization called OWASP. It's Open Web Application Security Project. And they figured out that mobile application is not exactly how a web application or a normal application is. I just gave you an example, right? So what they decided was they decided that they will figure out a separate top 10 risk which a mobile developer needs to understand. So if you're creating your application for your company, you need to know about the OWASP top 10. So in 2013, they came up with the top 10 security threats a mobile app faces, and how you can fix that. So that's what they came up with. So at AppNox, we have scanned more than 500,000 applications. We keep scanning all the whole Play Store. We have lots of clients whose applications we do scan. And these are the results for July 2019, this year. So these are the top 5 of the top 10 OWASP mobile list category. So the first is weak server-side control. All right? Again, what I said was mobile is basically a client-side application, but it always requires a server side of it. So weak server-side control would be where the server side is not being protected properly, because probably you just are creating a mobile app. You're not concentrating on how the backend works. And around 80% of the application which is there across all the security analysis which we have done, including the app stores of both Google and iOS, 80% of them has this problem, right? Uh, Insecure data storage, up till 2014, phones used to come with an SD card or a removable card. Apps were storing data in there just to save the internal memory. Now imagine your credit card number being stored in a removable storage, which you throw it out, right? Or if you're storing data in the sandboxed environment, but with a lot of privileges and permissions, that's the problem. So insecure data storage, we figured out around 43% of all the applications which we have scanned overall has this problem. Insufficient transport layer protection, again, how many of you have seen a red alert page whenever you open a website which has an SSL misconfigured? Like, have you seen a red alert page? Yes, amazing, right? Yes. So if there is an SSL or a CA mistake which is there, it will throw you an alert. It will tell you, are you sure? And then you click yes. Then it again asks you, are you 100% sure? And then you say, yes, let's just move on, right? But in a mobile app, those things does not happen. As a developer, you have to code those things, right? So as a developer, you can even bypass all of those security measures and controls which are there in the SSL and in the TLS transport layer protocols. So there is a talk which is happening parallelly where it talks about how to implement TLS in Java. You can go and attend that also. That's really interesting talk. That talks about this itself, like how you can protect the transport layer of your mobile apps. Unintended data leakages. Now, the thing is, since we are a Java developer and we know this Java programs are going to run mostly on the server side, you have lots of logs. But since this is a client-side application, and if you have logs or you are logging in important sensitive information, any other application can read those logs because it's running inside your phone, and all the logs are getting in your phone, and any other application can have permission to read those logs. So that's unintended data leakages. The fifth one is authorization and authentication. How many of you know about authorization and authentication? Does anyone know the difference between it? Okay, I can see just few hands. Okay, 1, 2, 3. Okay, just to give an context for everyone, authentication is to identify yourself, who you are, to an application. Like a login form is an authentication, and the permission to access a resource is authorization. So just to give you an example, if you are a user and if you have a permission to access an admin-related things, there's an authorization failure. But an authentication is to identify yourself, who you are. So there's a lot of problems in authentication and authorization in mobile apps, again, because of session handling is also you have to do. A developer needs to perform their own session handling. It's not taken care automatically as how browser does it, right? You do not write cookie management programs even in front end because browser does it automatically. You know that if you put the cookie value in the header, the browser is going to figure that out. But in mobile apps, you need to code it yourself, unless you're coding in PhoneGap or any other framework which kind of handles it for you, right? The other 5 categories, which we did not see a lot of problems, but the categories are broken cryptography, which means that you may be encrypting the data and storing it in the devices, but what if the key to the data, to the encryption, is hard-coded in the application? It's pretty easy to get those encryption keys, right? So that's one. Client-side injection is, again, this is a client-side application, so you can have access to run code execution on your phone because of vulnerable application. That's client-side injection, followed by security decision via untrusted inputs. That's again, let's say there is an input, and let's say it's a credit card number as an input. Just imagine this: you put in a credit card number and you copy that. So when you copy the credit card number, basically it gets stored in the clipboard. And that clipboard is accessible to any applications which is out there. If an application is running on the background, it can basically inspect your clipboard and get your credit card number instantly, right? So that's what. And the last thing is lack of binary protection. Since this is not running in the server side, you can basically decompile the whole application and figure out the business logic of the applications. So in 2016, we discovered that a lot of the issues which I talked about for the 2013 OWASP has been deprecated. There are a few new issues which have come up, and that's how they came up with the new top 10 list in 2016, which was published in 2017. And this is what you will get to see whenever you search for OWASP top 10 if you're building a mobile app, right? So these are the top 10 issues for 2016. The first is improper platform usage. Now, you might have a phone which has, Touch ID protection or Face ID or, fingerprint scanner, but those are the APIs given to you by the OEM and the device manufacturers to you. But if you do not use it properly, then it's of no use. You can bypass the whole control. I'm going to show a demo of that also. The second is insecure data storage. It remains as the same as the previous one. Third is insecure communication. Now mind this is insecure communication and not transport layer protection, because it also talks about how Bluetooth protocol works, how NFC protocol works, how you're going to do card payment to contactless services, and all of this falls under insecure communication. Followed by insecure authentication. The authentication and the authorization module are broken apart into two pieces. Now, authentication itself has a problem because you need to manage the session tokens and all the sessions, everything you have to manage. Followed by insufficient cryptography, of course, the same thing as the previous one. Authorization, I've already talked about it. Followed by client code quality. Now, since a lot of fragmented applications are there, code quality becomes an issue. A lot of other programming languages came up, like which people try to implement on top of the mobile phone programming. For example, Flutter or Kotlin. So all of these languages were tried to be implemented inside Android so that it becomes easier for you to refactor those codes and to maintain the code. Code tampering. Now this is a new thing where I can decompile the whole application, change the logic, and tamper your code and run it. But these are these different problems which is there. How resilient your application is from code tampering. That's what the problem is. Reverse engineering, of course, it's still the same thing. And the last is extraneous function, which means that as a developer, you may have a backdoor in your application just for your debug purposes, right? Or you may, I don't know, put in a password, an admin password in the comments, right? Remember, this is client-side application. If this app goes into the Play Store, and if someone does reverse engineering and figures out this is the comment which was written by you, which has the username and password of the application, probably that's where the problem is, right? So these are the new top 10 of mobile application security, which was released on 2017, but was written on 2016. So out of this top 10, which I talked about for the last few minutes, I'm going to show you the top 5 issues of this. And I'm going to show it with a demo. So this is going to be a video demo rather than my coding demo, because it'll take much more time for me to do it. So the first thing which I'm going to talk about is improper platform usage. Now, I just talked about it, right? If you have a Touch ID phone, enabled phone, or a Face ID enabled phone, and if your application has this thing like, you can log in using a Face ID or Touch ID, but if as a developer, if you have not implemented that properly, it will have issues, right? In this example, the applications which are shown is PayPal. It has been fixed. That's why I can show it to you guys. The other application which was shown is basically something by Intuit, Mint, which is. So this is the PayPal. So I'm just going to show. So it asks for the Touch ID, but you can click on cancel. If you click on cancel, it asks for the password, right? Very simple. So what this guy is going to do is he's also going to show you about the Mint. In the Mint application, same thing. You either enter the Touch ID or the passcode, or you just click on cancel, right? And you cannot go forward to the other screen. Pretty good application. But they are not using the device API properly. So what he does is He uses something called FRIDA. It's a security term where we basically instrument the application and change values on runtime. So that's what he does. He changes the value on runtime, he clicks on cancel, but he still gets logged into the device, right? Because on runtime, it just sends a value saying, yes, the fingerprint has been scanned. So because the developer did not verify it properly. The other one is the PayPal. He's just going to type in PayPal over there. And then when he runs it, this time the PayPal app is going to open up. And again, it's going to ask for the fingerprint, Touch ID. But he clicks on cancel, and he is logged into PayPal, right? So it's as simple as this. Like, if you have any phones, I can do it right now. I just have to set it up. But this is as simple as how you can bypass Touch IDs and fingerprint scanner or Face IDs if, as a developer, you have not implemented it properly. The next one is about insecure data storage. Now, before I show this video, has anyone heard about something called juice jacking? It has nothing to do with juice. It's something to do with power, all right? So I've seen it in many airports. Even airport in Sofia also has it. It has a charging station where you connect your phone. If your phone has a low battery, you go there, you charge your phone, connect it. Have you ever wondered what's connected on the back? Is it connected on an adapter or a system or a microservices? Who knows, right? So juice jacking is something like that. What if I attach a system on the back and any phones which is connected on the charging portal to charge your phone, I'm going to get all your pictures, all your documents, all your apps, all your app backups, and things like that. So this is something called juice jacking. This happened in US. I was in Black Hat giving a talk, and there is something called wall of shame. So basically, all those people who have connected their phone in the hotel to charge their phone number, their contact list comes in the wall of shame saying that they are not aware of the security bad practices which can happen. So this is just an example of an app. It's a very vulnerable app. So when you log into the application, it basically saves the username and the password inside the phone, which you should not do. And it also saves it inside a folder called Documents, which is basically publicly accessible. You do not need a jailbroken or a rooted device to do that, right? So as you are typing in the app, admin and password probably like this, and you save it as if you have saved it. Now, all this guy is going to do is go inside the application folder, and this folder is accessible. You do not need a jailbreak or a rooted device for that, but he has a jailbroken device. He's just showing it. So as you can see, the folder over here is Documents, and in Documents, he can do a PLUtil, and he can get the password and the username, as simple as that, right? So as a developer, you should not be storing all of this, and 45% of the application right now has these kind of problems, right? The next is insecure communication. I just talked about it. Web browsers has already solved this problem. You do not need to care about it. But if you're developing a mobile app, you need to care about how you're managing the session, how the cookies are being stored, how you're storing the tokens. Can the tokens be stolen? If you're logging out, are the tokens getting expired or not? And things like that, right? You need to keep a check about all of those. And man-in-the-middle attack is pretty much possible in a mobile device. And there are ways to do that. So this is basically a proxy. It's called Burp Proxy. You guys can, it's free tool. You guys can install this proxy in your laptop. If you're developing an app, you can use Burp Proxy to perform an automated network audit of your application, right? And this is followed by something called insufficient cryptography. Again, as I was talking about how insufficient cryptography has a problem. So basically, these are the top 3 problems, which is static seed for the cryptography functions. So if you have a static seed, you can kind of figure out what would be the next generated number. The second is static keys. So let's say you are doing an AES encryption, and if the key is hard-coded inside your application, it's of no use. Anyone can get that key and decrypt data all over, right? And the last is low iteration counts in PBE or salts. So iteration counts has to be more so that the entropy is much more higher. So it's not easy to break the encryption keys. So that's about insufficient cryptography. If you guys have any questions, you can stop me and ask me, by the way. All right. OK, and I was talking about extraneous functionality. So in this case, it's pretty simple, as I said. Let's say you have a PhoneGap application. A PhoneGap application is basically a mobile app written in JavaScript and HTML, right? Let's say your JavaScript has some extra function, which you have commented it out. In this case, I'm not going to tell you. So the name of the app is OWASP Go Droid. It's a pretty vulnerable application. And if you use that, it has the password hard-coded as a comment, right? So if you go through the JavaScript file of that application, you can figure it out that the password is hard-coded, but as a comment. So you can go ahead and use the password and work on it. Again, the problem is mobile applications over here are pretty much client-side application. So whatever you will write as a logic is available to general public to see through. They can do a decompilation of your application and figure out all the business logic your application has. So that's the problem, right? OK, so coming to the very important slides. Who do you think wins, an Android or an iOS, right? So there are a few places where Android wins. Not wins, basically. It's on a tie level. And there are, obviously, some places where iOS wins. This is, again, the data which I have got since July 2019, after scanning through all the applications which is there in the App Store, the Play Store, and everywhere, right? So for the iOS devices, so the first thing is vulnerable applications in iOS device is around 80%. It's 82% to be exact, as of July 2019. But in case of Android, it is around 85%. It's almost similar, the amount of vulnerable applications which is there in the App Store, which breaks at least one compliances, right? So these are the amount of applications which is there. Followed by malwares, right? For iOS, malwares is less than 10%, but there are applications which are kind of a scam apps, like you pay for that application and it does nothing, or it is intended to fool you people. But for Android, there are a lot of applications, around 75% apps, which is there in the Play Store, have malware or malicious capabilities. For example, if you have a flashlight app, why is the flashlight app asking for address book permission, right? So that's a malicious intent. So around 75% of the applications which is there in the Android App Store has those kind of problems, right? Followed by device vulnerability. This should not come as a surprise. Almost 100% of devices in iOS and Android are vulnerable, all right? So iOS came up, so it's recent vulnerability. So have you guys heard about jailbreak and rooting, right? So jailbreak and rooting is basically nothing but a device vulnerability, device level vulnerability. So jailbreak is a way you can get a privileged user inside an iPhone, and a root is similar to get a privileged running process in an Android phone, right? So these are the two differences between jailbreak and rooting. And right now, today, all the Android version can be rooted, or if you install the open source version of Android, you can basically get the rooted version of it. Today, till iOS 12, everything can be jailbroken. Even iOS 13, if you have devices like iPhone 8 and below, even iOS 13 can be jailbroken using, there are jailbreaks, which I'm not going to name. But the problem is iPhone 8 and below, they have something called hardware-based encryption and hardware-based device authentication. So there's a security guy who found out how to bypass those authentication, and that's called boot-ROM exploit, basically. So all devices below iPhone 8 can be jailbroken, although, Apple cannot fix it via a software patch. So So that's there. So 100% of the devices which is there right now in the market are vulnerable. Followed by the last thing, which is fragmentation. For the iOS, the fragmentation was really low. It was less than 10%. It has increased in July 2019 with the introduction of iPad OS. It's a different OS for iPads and different OS for iPhones. So with those kind of fragmentation in the OS layer as well as in the device layer, things have changed. So the fragmentation has gone a little bit high. It's around 20%. For Android, it still remains as 70% and above. The reason is, still now, people are using really older version of Android, and there's a lot of fragmentation of Android which is there. So if you're using products like MI or Samsung, they do not actually use the real Android. They actually fork it, and they have their own version of Android which they basically use. So these are the kind of different bifurcation of the real Android OS, which happens. So the important thing over here is to understand it's not about the platform or the device, but it's about how you create your application. I've given you some few examples of OWASP top 10 of both 2013 and 2016. I've given you a few examples of how you should procreate while you're creating the application, how you should understand how mobile applications are different than how Java applications are. So next time when you're developing a mobile app, make sure that you go through the OWASP top 10 list, especially the latest one, the 2016 one. There's a new list which is getting prepped for 2020. Probably it's going to come out next year, end of the next year. OK, so this is something which I wanted to say. If you think you have never been hacked, you are wrong. You have not yet detected the breach as of now. So that is why do not be a snail who cannot even detect whether you have been hacked or whether you have been breached or not. Go to haveibeenbond.com. That's a really nice site. And just search your username and see if those usernames are available in the darknet or not. Second is, don't be a turtle where you can detect the breaches, but you do not have the time to fix those. Right? If you are a programmer and if you're using best coding practices, yet you do not perform pen testing or you do not perform the best coding practices, but due to the time constraint, you have to code it in an insecure way. That's wrong. So do not be a turtle. Instead, be a dolphin, where you can detect issues swiftly. Use something called DevSecOps. That's a new term raging now. So basically, try to do a continuous security audit while your CI is building your applications and figure out what are the security issues which are there in your apps so that you can fix it immediately. And aim for a flying fish. Basically, predict cyber threats even before it happens, which means at least go through the news, figure out, follow Android Security Bulletin. If you're an iOS developer, follow Apple Security Bulletin, which publishes new issues which they have discovered every single month, right? All right, so with this, I'm going to end my presentation. If you guys have any questions, really happy to answer.